but gave $10 for this. I like it. Still got the guy's original call sign on it. It's an Olson717, and I put power to it. Didn't do anything, just drew a lot of current. So I think I'll break down and get a schematic for this. When I saw this, I thought, well, that's not the original mic, but that is the original mic. I found a picture, some advertising. So all I did was blew it out with the air compressor. Got all the tubes. Speaker looks fine. It's got the, that's what I was looking at, the 6 volt, 12 volt vibrator, so you could run this off a car. Underneath, it's got a lot of mica, so it shouldn't be that hard if it needs capacitors. Well, I bought this handy little unit, but it needs to be charged. But it can check the capacitance, and it can also check the ESR on these. So I think I'll test those when this charges up. I think if there's a problem, it would be this one. And I took my tube tester apart to clean it, so I can't test these, but there's not a whole lot to it. This is not used if it's plugged into the wall, so, but it's pretty cool. So I went ahead and ordered the photo fact, which is kind of nice to have. And I broke down and ordered some capacitors. So I was putting them in my Olson. But I was working on this can capacitor right here. It's kind of interesting. If you look, if you zoom in, that's original. Those weren't soldered in. I don't think either one was soldered in. This resistor here. Yep. They were just crimped over enough, probably enough to make contact. But that's kind of interesting. So I'm going to go ahead and replace that. So I got most of it off, and here's another wire that wasn't soldered on down underneath. See, it's just crimped on there. Hopefully I'll fix that. So it may not look pretty, but I got those replaced. I was testing this. I got this on eBay, man. I love this little thing. It's cool. B loss 5.4, ESR 0.49 ohms. So they're all kind of bad. This thing is rechargeable, but the battery doesn't seem to hold a charge. So maybe I'll get another one, but I also went and bought, I saw these at Lowe's, but then I went online and got 2 of them. Put those in, so it's got like 2 USB ports, which is kind of nice. So I'll go ahead and try to turn this on, see what happens. So it took me a while. I had to find a bunch of 1 amp fuses. I'd burned them out previously when I first got this. I thought I could make I thought this little wire right here looked about equivalent. Thought I could make my own. That little wire right there will carry 4 amps. That don't work. But anyway, I found some fuses. Got a light. It's humming. Nothing smoking. So the way this worked, you could run it on crystal. I just put a little antenna on it, or you could tune it. Okay, there we go. Okay, squelch is backwards from so that squelch is on, off. Well, it's working somewhat. Turn the light out here. I don't smell anything burning. I'll let it run for a little bit longer.
Take care. Because you know I care. Be in this station right downtown, beautiful Long Beach, California. I'm laying it down. I'm trying to read this U.S. mail. They 26 still. I'm gone now.
So we're talking on 5 and 6, so it's picking it up on 3. Adjust that. And I just have a little antenna. It's a 2-meter antenna actually, but some skip coming in. So I think next I'll try to align it. So I got my Olson717 up and running. It's receiving good, it's transmitting good. This is really the first alignment I've done on a radio, and it was pretty quick and easy. I had another old GE radio I messed with. I broke the tuning slug in that. In another radio I was going to practice on, I broke the tuning slug in that. So on this one I was really careful to make sure and kind of work them loose before I started turning on them. First thing I had to do is I had to make an alignment tool. I didn't have one, so I took this old this is a knitting needle and I had a wood lathe, so I just turned it down. I made a, and then X-Acto knife made a tip. I just broke it a while ago prying on stuff, but receives fairly well. And when on transmit, the audio is surprisingly clear. It sounds like it's a little bit undermodulated. It's got this thing with speech clipping. I don't know what we're at in the circuit it does that, but I think it's just to prevent it from overmodulating. So maybe with a power mic or something, audio might be a little stronger. I kind of wish I had some sort of, this is the photo fact for it, but here it is. In 1966. I guess they made it in 65, 66. 66 the best year, or no, 65 the best year, because that's the year I was born. But I get the gist of how it works. I got kids fighting in the background. Let me see. It's a little complicated because it's a transmitter too, not just a receiver. But like, so your signal comes in here, and these points are where you peak the the RF output. These two. There's another one over here. But signal comes in here, goes up, get your first RF amp, and it goes over to this mixer. And down here, there's a switch, crystal or tune. So if it's on crystal, this is a crystal controlled oscillator. And if you turn that off, and this is like a variable frequency oscillator, it goes up there. The first filter, band pass. IF amp, the second one. And then from there, the squelch. This is kind of confusing, but I think this is just the audio amp for the speaker. But it kind of does dual purpose on the transmit too. You just hook up your meter to here. So you peak these. There's a slug on top and then on bottom. So that was pretty quick. And then down here, which this is a different oscillator for the transmitter. So it's only crystal controlled. This is kind of the strange part because here's your mic, first speech amp, second amp, and it goes up to here, and it calls this the output modulator. But I don't see how that could modulate because there's no RF getting to here. So I think what it does, it goes down through the primary coil of the speaker all the way over here, whoop, down, and the RF amp, final amp. So here's your oscillator, it's going into this little screen here, and then this one here. I think this is where it's combined and out to the antenna. And also it says transmit oscillator doubler. So if you look at it, so for example, like this is the 2 for channel 4. So your channel 4 is 27.005. So your receive crystal is 27.460, which is 455 above that. Then your transmit is half of it. So if you double that, you get that. I don't know why it does that. Maybe just the nature of that oscillator, it doubles it. It seems like, why wouldn't they cut a crystal to oscillate at that frequency? But that was that. My main problem I had was I took all these crystals out. I was going to clean them, and so this is a transmit crystal here. So I assumed that this bank was all transmit and this was receive, and that was a bad assumption because then it didn't work. And I tested all kinds of things. There's a rotary switch here that was all corroded. I cleaned. It also gives you some points to check voltages and resistance. But everything seemed fine. So I just started swapping crystals around, and I found out that it would transmit on these 4. So I was looking through, thinking, well, it transmits on these. I found a good crystal. Finally, it transmit. Then of course, what I should have done in the first place was look. So there's your transmit, there's your receive. So it's like in 2 banks. Transmit, receive, transmit, receive. So once I got that figured out, and then these back 2 down here are swapped. The front are swapped. So you got a transmit and a receive. Maybe they did that just to put that. So that threw me off. But once I got that done, figured out. Everything was easy after that. Because I didn't know it wasn't transmitting and receiving. I thought, well, it was a bad tube. I can't test the tubes, or something else is wrong. So I got on off course there. There's one thing that's not working right now, and that is the spotter. And so apparently when these were new, it only came with one set of crystals, so a receive and a transmit. And I guess that was to save money. And I seen in old advertisements you could buy sets of these. So you could get 1, 2, 3, 4, 5, 6, 7, 8 crystals, 7 in here and 1 outside to transmit on. And if you have 8, that's 16 crystals. So you're receiving and transmitting on 8 frequencies. But if it's 23, there's still 15 more channels, and that'd be an additional 30 crystals you'd have to buy, but plus you'd have to open up the case to put them in. So I think what they did is you would just buy the transmit frequencies you want. You plug one into here, and I don't have a user's manual, but apparently how it works. So what you do is you put it on the tune, and this is a spotter. You put that on. Let's say, for example, this was 19. It's right there. And you key up the mic, and then you tune this, and I think it should produce an audio tone. The light should come on, and then you could tell by the meter. So that way you have your receiver tuned to the exact same frequency you're transmitting on. So, but that's not working. And if I look on the schematic here, I replaced. So if you look here, this is spotter, and all that does is through a capacitor to ground on that section. But down here, this is the other side of the switch. It has something to do with these two capacitors, and these are like 5% values. This one, I think this is the other one. I don't know what MPO stands for, but apparently they have to be within that range. And those are two that I didn't replace. That's this guy right here and this one. Those are the only two I didn't replace. So I think that's probably the problem, because there's nothing else associated with that switch. But maybe for a later date I'll mess with that. So that's it.